Thank you. Sound okay? All right, good. So I will be talking about OSIsoft's cloud services, security specifically. Um, OCS is a data storage it's a cloud service and data storage. And I'm not going to be talking about OCS in general, but if you wanted to understand more about what OCS is, there is a talk two doors down after this one. So when I started to do this talk, I wanted to figure out a way to talk about what security would mean as far as how would you secure an infrastructure. And there's a lot of responsibilities associated with getting your system to a secure state. And when you employ a cloud service, you end up sharing a lot of that responsibilities. And this graphic does a very nice job of explaining how the responsibility is shared. So on the far left, you see that a lot of these responsibilities are taken on by the cloud provider. And the cloud provider for OCS is Azure. And then the service provider in the center, that would be us, updating the application and keeping it up to date. And then it moves far on to the right, where it becomes more of your responsibility, and that is with the governance of the data, access to it, and the access management. And if you're interested a little bit more in about this shared responsibility, there is information about it on the OCS portal. Another way to look at this problem is an analysis that was done by the Australian government. So several years ago, they did a case study of vulnerabilities or attacks that had occurred in the Australian government. And they came up with 4 different things that could be done. And they called it, at the time, their top 4. And if you have seen some of the talks from OSIsoft on security in the past, you may have heard us talk about that top 4. But as all things evolve, they added to that top 4, and now it's 8. But the reason why I included this list was to talk about the fact that all those responsibilities for securing the system when you're deploying it yourself fall onto you. But when you use a system such as OCS, a lot of those responsibilities are shared. So there's a lot of things that were identified as securing infrastructure that you get for free by using a system such as OCS. Now, when we began to tackle the problem of how we were going to add these types of security measurements into a system that we are maintaining, the development staff had to solve these problems, and these are the ones that I believe are worthy of discussing, especially based on the approach I took referencing the defensive measures. So we wanted to be able to have a consistent and reliable way to configure systems. That's not only just the operating systems, but that's also just how the system is configured to operate. Dealing with updates, I know that many of our customers complained to us in the past about patch management. And that's not just operating system patch management, but that's also management of the software, of our software itself. Being able to do continuous testing so that you can make sure that you are in a reliable state as you apply updates or as other circumstances, just making sure you're continuously working properly. And infrastructure to have reliable access to data so that you know that it's always available and always stored. And in order to solve those problems, we are using a concept of deployment environments at OSIsoft, in OCS specifically. And the best way to describe this concept is to focus on production. So I think it's pretty clear in our heads when we talk about a production environment. So that is right now the cloud.osisoft.com. You can imagine there are multiple services and multiple computers up and running in order to provide you that service. But what happens when development needs to add or modify that? You don't want them going in and making ad hoc changes and innovative updates in the actual environment which is running and has your critical operations data. They need to replicate that environment for their own play area. So you can certainly see that we would need to produce some sort of deployment environment for our development teams to do active and active development. So you just take that concept forward, and you can think that it would be very useful to have deployment, testing, integration, and pre-production before actually going to production environments. So it becomes a very good way of forcing us to test in different, almost like sandboxes, I guess, if you would. Now, there's a lot of advantages and benefits to doing this type of approach. You can imagine with all these different environments, in order to just get them configured correctly, you're being forced to use code to configure them all. You can't just manually configure all these environments. It would become completely unreasonable. And you want to have a situation where the environment you're using is behaving the same way as the production environment. You never want to hear a developer say, well, it worked in my environment, I don't know why it's failing in production. And the approach that we use in the architecture also allows us to do this continuous update process. So it's a lot of, and just the fact that we have multiple environments, we're continuously testing just because we have to do the same thing in multiple environments. But rolling out patches for the operating system and updating the software and being able to go back to the previous state if there's a problem, our infrastructure allows us to do that. The graphic along the side, I kind of included that because it was a kind of a clever looking way to just get you a sense of the volume of these different configuration of codes that we deal with for setting up an environment. But the next picture that I included is something called chaos testing. That this Medusa picture is kind of cool, I think. But chaos testing is a concept which comes up in this type of a development scenario where you want to throw randomness into that environment. So what if a service fails? Well, instead of just, we think we solved that problem, what if we actually force it to fail and make sure that we recover properly and correctly measure the fact that occurred, and our analysis tools detect that failure occurred. And that's all what chaos testing is about, and we try very hard to take advantage of that capability, and we do have chaos testing in our environments. We do monitoring and analyzing of the environment continuously, and the architecture is built to support highly reliable and distributed databases. Now, the next question that I wanted to tackle was the availability of the data, and there are a couple of things that we do to make sure that your data is continuously available. We deploy and use a distributed denial of service protection, and then in addition to that, we are able to scale up the resources as peak demands occur in order to make sure you continuously have access to your OCS resources. Here's another way of looking at those two different the protections that are offered within OCS. The load balancing, which is where a lot of the work is done for the distributed denial of service. And then we have an OCS Gateway as a second layer of protection, which is where the authorization is completed to make sure that you actually have the access that's required to get to the OCS resources. Now, one of the questions that I was concerned about is the network that your sensors and PI system, is it safe from OCS? You know, obviously they are sending data up to the cloud services, but in the security world, we tend to take a very skeptical view of the world, and we kind of turn it on its head and think, what if? Well, what is the worst thing that could happen? OCS could become attacked, it could become evil, and it could be doing nefarious things. So let's kind of put ourselves into that mindset. That worked a little better than I thought it would. So now OCS is evil, and what's it going to do? It's going to try to send stuff down to your sensors, and it's going to try to attack them. But because the communication channel is one way only up to OCS, it's blocked. The evil OCS does not have any network credentials into your network, and it doesn't execute directly on your network. So that evil attack is actually contained to that portion, just OCS. And you go, okay, Mike, you know, what about the agents? You have to have agents that are on our network in order to send that data up, and that's true. they could possibly they could come under attack. And the protections we use in those is to apply least privilege concepts to those agents so that they can only do what they are intended to do. They can only send data up to OCS. They're not configured to be able to do attacks on your network. They don't have those necessary privileges. The other thing is that we sign all of our executables so that you can deploy and use whitelisting application whitelisting techniques within your network to make sure that if the application were altered, it would no longer be signed properly and it would fail your whitelisting protections. And then I had a little more fun. I shouldn't have. I gave him a goatee. It reminded me of Spock. So anyway, is my data safe? Theft and tampering. So in order to make sure that we're dealing with the theft of your data and tampering, there's a couple of things that we do. And one is that we want to make sure that we do best practices for authenticating access to your data. And in order to do that, we're working very hard to make sure that we support the latest in identity standards. And we want to give you control for the authentication as well, so that you can take advantage of best practices that are available. And we have seen the evolution of the identity industry. There's been a lot of evolution in the identity industry for the last several years, and we expect that to continue its trend. So we wanted to make sure that the architecture that we picked would allow us to move with what we're seeing as industry trends. So in addition to all that work we're doing with identity, we also make sure that as we save the data, we do fully encrypt it at rest. Now, I wanted to talk a little bit about the evolution of security in general to cyber assets. So several decades ago, if you had a computer, you most likely had it in a locked room with security guards, and that was all we could do for you. And then as we added networking capabilities to our computers, the next level of protection became firewalls and then VPN access into those networks. But as many resources are becoming internet-based resources, a lot of companies are getting their assets and their resources from cloud services. And when you have a cloud service that you're trying to protect, there is no firewall from your corporation involved in that protecting. So the only protection that you've got left is identity, and identity is the new frontier, the new perimeter for protection to your corporate assets. And beyond the fact that we are moving for convenience sake to internet accessible assets, there are a lot of issues and well-known attacks against your network, principally phishing and credential thefts. So if one of these attacks is very successful, they're going to be in your network. And once they're in your network, they're able to freely move around. So all the more reason to abandon the approaches, well, to move away from the approaches of the past of network and build for an architecture of the future focusing on the identity perimeter. And the most innovation and the forefront of this field right now are two standards, OpenID Connect, which is built on OAuth 2, and that is the approach that we are using, OpenID Connect. Now I'm going to talk about identity from two perspectives. One is the human identity. I think we're all familiar with that. Simple logon, a very interactive process. You type in your username and password, and sometimes there's some sort of challenge, like in this case, clicking that you're not a robot. But with machines, there is no interaction. It has to be all silent. So I'll be talking about the differences between those two different types of authentication. Now with human identity, the approach that we're using within OCS is to be authenticated by your identity provider. We federate to your identity provider. And because we do that, we are able to give you an architecture which allows you to leverage the latest in industry standards for authentication processes. That includes multi-factor authentication, IP address blocking or restrictions, geolocation and geofencing capabilities, FIDO2, which I think is going to be really interesting in the next several years as it gets us to passwordless authentication for people, and threat intelligence challenges and responses. So all of that were things that we were able to deliver to you, not by implementing them, but by focusing on federation processes where we are able to integrate appropriately with your identity provider. Now, the human identity providers that we currently support are Azure Active Directory, Google, and Microsoft Live. Now, I'm going to focus in now on machine identity, which is a little bit different. Here we are using the current standard from OpenID Connect of a client ID and secret. Now that is effectively just a username and password. And the protections that we offer for that authentication include HTTPS only. You can revoke any of those credentials. The client ID has limited access, and it has no access whatsoever to your network. This is only access to within OCS, and the access for the sensor is limited to what it needs to send data to. Secret expiration, you could, if you want to do secret rotation, we do support the capability of expiring the secrets. And the secrets themselves are very strong. They're 32 bytes and cryptographically random. So just to give you a sense as to how secure a 32-byte or 256-bit password is, you could compare that to a 32-byte or 32-character password, and so you can just see that how long it would take to brute force attack based on these numbers, a 32-byte password. Now, machine identity does have a few problems. One of the biggest problems that we are facing now is the simple fact that the industry, the identity industry, is not as strong in machine identity as they are in human identity. I think a lot more focus has gone on there. We want to be able to come up with a way to deal with credential rotation for these machines. The onboarding and provisioning of machine identity is very challenging. It's labor intensive, often involving an administrator to execute that. And because of all that, it really doesn't scale when you have a case where you're trying to provision hundreds of devices at once. And if we look at PKI for certificate-based authentication approaches, it faces equally difficult challenges with the onboarding and rotation business cases. Now, I'm going to start talking about future and things that I'd like to see us doing. We as OSIsoft would like to do it, but I can't guarantee when this kind of stuff is going to happen. My objective in talking to you about this is that if you have ideas or you have thoughts about where identity could go based on this conversation, I would love to hear some feedback from you. What we'd like to be able to do is getting our devices to self-register, rotate their own credentials, and support certificate-based authentication, not only self-signed certificates, but also manufacturer provisioned or PKI provisioned certificates. And just like we did in the human identity case where we were leveraging your identity provider, we want to also leverage your identity provider for the authentication process for machines. And how we will do this, and this is kind of an overview of how OAuth tokens work, and I'm talking about how we're able to architect to use OAuth tokens and support both the standards compliant way of doing client ID and secret, and also certificate-based authentication. So in certificate-based authentication, that public certificate is going to be sent down to the identity provider, and it's going to verify the identity of that machine, and then it'll send back an OAuth token. And that OAuth token contains all the authorization information necessary for that machine to access and execute OCS services. So that token can then be sent on to OCS, and those services are executed. And one of the things that's kind of cool about using certificate-based authentication over client ID and secret is that when you do use when the client has a certificate, we're actually able to increase the encryption on that communication channel from a one-way TLS, which is what is most commonly used in modern internet transactions, but we can actually update it to a two-way TLS to get a stronger communication channel. The only other thing I didn't talk about was the private key, which is represented on the screen. And the reason I left it there is to point out that the private key never left the machine. And that's one of the things that's cool and makes certificate-based authentication much better than client ID and secret, which is good, but we're always looking for better in security. And that's why we're hoping to plan for this better future. But anyway, the advantage there is that key never left the machine, so there's less chance to steal it. Whereas the client ID and secret had to be transmitted, it had to be provisioned by an IT administrator, so there's lots of exchanges going on there, lots of opportunities for that to be stolen, used someplace else successfully. But since the private key never left the machine, there is less opportunity for it to get stolen, and even if you steal the public key, it's useless without being able to prove that you have the private key that goes with it. And that's why we're very excited about the idea of providing certificate-based authentication. And now the provisioning of this certificate-based authentication can be done a couple of ways. First, so the machine will have to provide the public certificate to the identity provider, and then the identity provider has to trust it. And how do they trust it? Well, you can either use public key infrastructure, which would include situations where the manufacturer provisioned that certificate. But the other thing that you could do is have manual processes where the administrator was involved and said, yeah, that's what was supposed to happen. That machine was supposed to be sending a certificate at that time or in that window or during that process, and I will accept it, and the identity provider is able to then trust it moving forward. Now, again, this kind of comes back to the point where I was making, where we want to be able to trust your identity provider. And in order to do that, we want to make sure that we follow and implement lots of standards. The standards that we want to use for human-based identity federation include WS Federation, SAML, and OpenID Connect. Now, for machine-based federation, we will be only focusing in OpenID Connect. And this is kind of cool. I put some geek speak on the screen here. These are all the standards that I just talked about. In the Cristobal talk, discussion points, none of that is stuff that we made up individually. We are following the different standards from OpenID Connect and OAuth 2. And not only are we working with making sure that we understand the standards, but we're working with security experts in the field to make sure that we interpreted them correctly. So if you are one of these people that likes these standards and wants to talk to someone about it, I would love to have that discussion. I should be at the cybersecurity booth a lot this week. You can stop by, or you can send me an email. And I can't do a talk on cybersecurity without talking about some of the wonderful things we do in the practice of developing secure code at OSIsoft. We follow what we call it's Microsoft Security Development Lifecycle, and there are many practices associated with writing secure code using this strategy. And I'll be going over some of them. And the first one that I've got on the list is the ability to use dynamic scanning. And a lot of the things I'm talking about is the implementation of best practices and tools. So dynamic scanning, we purchase a couple of tools. We purchased one from Qualys and one from BitSight. And what it'll do is that tool will go out and try to hit your websites with common vulnerabilities that are well known. And a lot of you have probably heard of OWASP Top 10. That's a good category of them, but there are others as well. But it'll go against your website or your web endpoint and try all these attacks and make sure that you respond appropriately with the correct defenses. And if you don't, it surfaces as an error for us to fix. One of the other things that we do is fuzzing. Now, this is a very interesting way of creating random data to throw at an application in order to crash it. And once you've identified that specific packet that crashed your application, we have a nice repeatable way to crash it, and then we can go off and fix it and then fuzz some more. And that tool is from Microsoft. It's called Microsoft Security Detection. Static analysis, there are so many security mistakes that are made by developers, that they are well known and categorized, and we have tools that can find them. And the one that we use is called Coverity. It's from Synopsys, and it does an excellent job of catching those common mistakes that lots of developers make, so that they can not only learn to not make that mistake again, but also make sure that we fix the code we've got, right? One of the other tools we have is called Black Duck, and that's used for helping us manage the components. So a lot of developers will use open source components, and the reason we do that is because it allows us to develop faster and more rapidly by not having to redevelop stuff that's already been written by someone else. But what do we do when those components that we're using have security vulnerabilities? How do we know? How do we know that we're out of date? How do we know when those open source components use other open source components, which use other open source components, which then have vulnerabilities? How do we know about that? And it's very difficult to keep track of, and that's where tools like Black Duck come in handy. It also helps make sure that we are complying with all the licensing regulations and requirements that we have in order to use those components. We do lots of engagements with security researchers. So who better to attack and attack our software than people that do that full time for a living? So we have a couple of research firms that employ hackers and researchers that like to attack, and we pay them money to attack our stuff. One of the most recent ones we did was with Black Hill. They did a research against our identity infrastructure. They found a really cool problem, and we fixed it right away. And we've done lots of engagements with other security firms, and the other one that I put up there is OAuth, which we've spent a lot of time working with. Two great firms. And the last thing I have on here is the development practices. So all of our development teams are concerned about security. Some of them come up with new and innovative ideas, and we want to share that with other teams. And we use this process of keeping track of what all those best practices are, and we measure our teams to see which ones are applying which, and which ones are more successful than others, and use that as a means to share information and make sure all teams rise. So in summary, I just want to make sure that you understand that there are fundamental concepts that are used in the development of OCS which naturally address security. Just by making us do the installation and managing of the system made us solve and address different issues which fundamentally gave you good security advantages, and that was where I talked about the Australian government's defenses. Also, identity is the new perimeter, and because identity is a new perimeter, we're spending a lot of time trying to figure out what to do there and how to architect for the future. And this is something that I would really love if you could do is we want feedback from you. Is there anything that you can share with us about your identity plans? Maybe the only thing you know is what identity provider you currently use. But maybe some of the concepts I've discussed you could share with your company and get feedback in terms of what they like, what they think you should do, and maybe you can share some of your identity and access management plans with us so that we can make sure that our plans will suit your needs moving forward. And that is it. So we got lots of time for questions. Yes. Oh, they're going to try to bring them. I think they want to get the microphone so that it's recorded so we can always hear your voice. It's been recorded forever. Securely, thank you. Yes, securely recorded.
You were talking about the OpenID Connect and OAuth, which is defined only over HTTP or HTTPS. What about the protocols non-HTTPS, which are in IoT and industrial IoT quite relevant, like MQTT, AMQP, and identities over industrial networks?
Yeah, we have looked into that, and if that is something you're concerned about, I'd like to understand. We focused we focused over HTTPS. We thought that was a good solid direction to go with. But we have looked into AMQP. Was it AMQP? I always mess that one up. AMQP. Right. Yeah, yeah. So we have looked into that. We have experimented with those technologies. We just decided to focus on the HTTPS.